Hey everybody, welcome to a special edition of the IBM Storage Ceph cast. We're creating a new series kicking off 2025, focused on some of the capabilities and features of Ceph version 8.0. The first episode is this one. There's going to be kind of 3 or 4 or 5 more coming on a regular basis, so look for future episodes as well. Very happy to be joined today by Daniel Parks. Daniel is one of our technical product managers for the Ceph product, coming to us all the way from beautiful Spain. So Daniel, thanks for joining. Appreciate it.
Hi, Randy. Thank you.
Hey, so all right, so we're going to kick this off by starting about storage Ceph replication, multi-site replication. So we've been talking a lot lately about kind of the advanced capabilities of Ceph, and I think we've really seen a lot of development and a lot of progress in terms of, robustness and feature parity and, resolving some tech debt and usability issues kind of since Ceph came into IBM. I know you and your team have been working very diligently. We've had multiple releases and we've seen some really significant improvements. So this is another example of that. So take me through the latest kind of state of the art in terms of Ceph multi-site replication. Let's talk a little bit about it.
Yeah, that's a very good point. So in that sense, there are also quite a lot of questions going around. Okay, I want to have Ceph, but I also want to have multi-site, maybe for DR, maybe for active-active. So the idea here is, okay, let's have a first session where we discuss like a very high level of the possibilities that we have with Ceph, asynchronous replication, synchronous replication. Let's go at a high level over all of these features. And then if there is interest, we can go on another episodes more into the details of each one. So with that in mind, again, I have here some slides just to give us a little bit of visuals, of graphics as we talk. But in any case, Randy, with whatever questions you have, we can have a discussion. Just to bring like a little bit of context, I had this initial slide here, really not based specifically on Ceph, but just resiliency in general, and we already know, that really the resiliency solutions are really based on service level objectives. So depending on how critical your application is, you can go from a very, very expensive solution with synchronous, with RPO 0, etc., to your traditional backup and restore to tape as an example. So there are different grades there. And also, depending on your needs, you can choose one or the other. I just wanted to show this slide to see how Ceph features fit into the resiliency solutions, and just to cover them very briefly. So talking about RPO 0, so the most expensive and the one that offers synchronous replication is really in Ceph what we will call like a stretch cluster. Here, normally we have data centers that are quite close together because you have the requirement for dark fiber, low latency, and you're able to offer RPO 0. So you're able to provide like redundancy for data center failures with this option. RTO, again, with stretch clusters, is going to be very fast, because you have the data completely synchronized and the application is just the time for the application to start in the other side, or maybe you're running active and everything is already going. So that's like the best solution if you have a very, very critical application. And then the second one is asynchronous replication. With asynchronous replication also available in Ceph, we are not providing RPO 0, but we are close to that very, very low RPO because we are doing constantly synchronization of both sides. It is asynchronous, so you can do it through a WAN. It can be geographically dispersed, So that's one of the advantages there. And then really the RPO is going to depend on the type of asynchronous replication that you're doing. Maybe it's journal-based, maybe it is log-based, etc. So that will make a difference. So both of these options are available with Ceph, and it's a little bit what we wanted to discuss today. Then we have restore and backup. That's the traditional, and it has the highest RPOs and RTOs that you could expect because it's not only the time that it takes with the RPO. When you take the backups, maybe it's every 48 hours, maybe it's every once a week. So your tolerance for data loss is going to be quite big, but also your RTO, because you actually have to recover that data from tape or from your nearline archive data
So
solution. So it's going to
the
take
point
some
here
time.
is that Ceph provides kind of the full range of resiliency solutions based on the requirements, right? So whether you want to go near zero or zero, up to and including kind of lower cost, more asynchronous backup and recovery. So cool.
Exactly. Yeah. So moving forward, just to give like a very high level, and then we can go a little bit into the architecture about asynchronous replication, or will be multi-site asynchronous replication. One of the main things to know here is that we have one Ceph cluster per data center. So if, for example, you're going to have 3 different data centers that you want to replicate between, it could be 2, it could be 3. You have one full Ceph cluster with all its redundancy in that Ceph cluster. There you have your replicas, you have everything that you would normally have to achieve your high availability and redundancy inside that data center. And then you're doing multi-site asynchronous replication between the other sites. As we mentioned, it is asynchronous, so latency is really not an issue. It can be geographically dispersed. It can go through a WAN. And the most important factor related to the network here, if you think about it, is really throughput, no? Because you need to be able, with the throughput that you have between your different data centers, you need to be able to ingest all of the data the clients are ingesting, but then also replicate it in time, no? Because if we're not able to replicate it in time, our RPO, our possibility of losing data is going to grow indefinitely, no? So we really want to make sure that we have enough throughput between our different sites to be able to manage all of the data that we're ingesting from our clients.
So the sizing and configuration of that is presumably part of solutioning a Ceph cluster, right? Or solutioning an architecture is kind of compensating for the latency and the network overhead. Okay, cool.
Yeah, is the tricky part here, as we are discarding latency that we will see afterwards in the stretch cluster, where that's a factor. Here, latency, we can more or less leave it aside. We just have to worry about the throughput. So when we're doing the sizing, the links, let's say, between the sites that we're going to replicate through need to be sized accordingly. The other thing that I wanted to mention here that is a little bit specific to Ceph is that the asynchronous replication is done at the service or daemon level. So just as an example, if you want to do asynchronous replication of object storage in Ceph, then the configuration for that object storage replication is going to happen in the daemon, in RGW, as we call it, on the Rados gateway, or the object gateway, if you want to call it. So we have to go into that client, configure multi-site replication, and then we will start enabling the replication for object. If you wanted to do the same for block, you have to go into the block service daemon and do a specific configuration there, no? So really, asynchronous replication is not happening at the Rados level, at the core level that I will show you in a moment. It's really happening per service, no, and per daemon, let's say.
So it gives you a lot of flexibility and configurability options. Yeah, cool.
Yeah. The only downside that we will see afterwards comparing with synchronous replication is that you need to know a little bit about each of them that you're configuring, because it's not configured exactly in the same way. Because for example, just an example, if you're doing block, you are going to do a snapshot block mirroring, for example. If you're doing object, you're configuring S3 replication through HTTP. So it also depends on the protocols and how you're doing it. But in any case, it's quite easy to configure each of the daemons. You can do it from the UI, etc. No? So it's quite easy to do. Moving forward, the other side of things, stretch clusters. So the main difference with a stretch cluster is that this is a single Ceph cluster. So we only have one cluster, but we are stretching it through our different data centers. No, when we stretch the cluster, automatically we are getting that RPO 0 because we're doing synchronous replication. This really means that if a client does it right, he's not going to receive the acknowledgement back until he has actually copied whatever replication scheme we have in place. No, so you are sure that all your data is saved into Drive in each of the data centers before the client is going to get an ACK and an acknowledgement. So that's going to really provide you out of the box with RPO 0. One of the advantages with the stretch cluster here is that this is really configured as a normal Ceph cluster. So we are really stretching the RAIDs, the OSDs. So the disks, the underlying layer that I will show you in a moment is really what is being stretched. So all of the higher level entities, all of these daemons, like the object storage, block, file, automatically are getting the benefit of a stretching underneath. So all of them work in the same way. And it's really nice for the operators also because they don't need to do anything special. You just manage it as a normal Ceph cluster. No differences there.
Nice.
The only thing, again, that, okay, we are running stretch. Now latency is a very important topic. So we have to be very careful. And it's very, very important. I will say it a lot of times today with a stretch cluster that we have like a solid, very reliable network, low latency, and also very, very important trying to avoid big spikes in the latency or between the data centers. Because sometimes you know that you do a ping and you see the round trip time and it's perfect, 1.5 milliseconds during most of the day. But then, for example, you go at night and you do one of those pings where maybe there's some tape offloading or any other thing going on, and suddenly those round trip times go to 15, 16 seconds. That's something that is going to be problematic. No? So the network with the stretch clusters is very pivotal and something that we need to plan very well.
Yeah. So network congestion and traffic have to be factored into the design pattern. Yeah. Okay.
Yeah.
Cool.
Yeah, and here I have this just a slide just to mention and go over again very quickly about what we stretch. No, so here this is our typical. I'm sure that most of the people have already seen this slide. This is a typical Ceph division in layers. We have here the RAIDs layer that is really where all of the intelligence of Ceph is happening. We have all of the replication, health checking, failure domains, all of the intelligence goes into RAIDs. And then we have the higher levels that I was talking about before, like RAIDs gateway for the object storage, RBD, CFFS, that is our POSIX share file system. Those are the higher levels. So when we talk about stretching a cluster, what we are really doing is that we are stretching at the RAIDs level. To understand ourselves, RAIDs is really like the OSDs. So all of the monitors, the OSDs are getting stretched. And the real benefit of this is that all of the higher levels automatically are getting our RPO 0 and our synchronous replication out of the box. And on the other hand, if we're doing a synchronous replication, is actually done per daemon, as we mentioned before. So here in this example for this slide, we would configure RAIDs gateway, that is the S3 object replication, and we will configure this one to connect to another Ceph cluster and start doing your multi-site asynchronous.
So you could actually have individual, very sort of granular SLAs for each of the services in that case, right?
Yes, yep, totally. You could have maybe for block very low SLAs and you're doing very fast snapshotting, and maybe your object storage is not so critical and you have less resources configured, maybe less throughput, etc. No? So that's perfectly configured and granular as required, depending on the use case.
Cool. Okay.
Perfect. Well, the other thing that I wanted to mention, just very quickly that I forgot, is that you can also mix and match. So you could have a stretch clusters, and maybe for DR, you're doing a synchronous replication of object or block, or maybe all of them. So you can mix and match both of these technologies. No, it doesn't mean that if you're doing synchronous, you can't do anything else. You can actually do both if you want to be doing synchronous replication and then sending out some data to another geo. That's also with a synchronous replication. That's also perfectly fine.
Okay, so this is great. This is a really I think a very good overview of the replication capabilities across all the protocols and across the different kind of RPO design points. So let's talk a little bit about use cases. Can you give me some examples of common use cases where replication and in either case, either synchronous, I mean, obviously synchronous replication for high availability and business continuity, but there could be Just give me some examples of common use cases for both the asynchronous and synchronous model.
Yeah, that's a good point. So, for example, for synchronous, we have an example, a customer where he really requires consistency at the S3 object storage level. So they want to be sure that as soon as you actually, let's say, do a put into one of your buckets, you need to see in all of your buckets, in all of the sites, the same data, because it's actually being consumed active. So you have different clients accessing different endpoints. So they need to be sure that as soon as you do one put, one write into a bucket, all of those objects are going to be available. Using the stretch cluster solution that we're mentioning, you are actually achieving that, no? Because you have full consistency, because as we mentioned before, we are not going to give the acknowledgement back until all of the data is actually in all of the sites, no? So that's an example of, okay, I have very strict requirements for my object storage. As soon as I write on one site, I want to have the data in all of them. That's a good example for object. With block, that's the other one that we get quite a lot. With block, we have to be aware that, and I will explain a little bit why we need to take into account latency between sites, no? But you can't, I mean, we have to be careful because like very high IOPS, low latency demanding workloads are not exactly the perfect use case for this. We have to take into account that some latency is introduced, no, when you're doing the jumps between sites, for example, for block. And to your point, Randy, and to finish the asynchronous example, so doing asynchronous replication for object storage is very common. No, I think that most of our customers are actually using it, so it is very popular. And there you could see all kind of use cases. Maybe someone that wants to have DR for their object storage, so they are doing active, passive. They have two sites, two full Ceph clusters. One is the one that's actually serving all of the data to the clients. If they have an issue in that data center, they want to be sure that they just have to change the load balancer, point to the DR side, and get everything up and running for their object storage really quickly, as an example.
Got it. So what are the design considerations or the configuration considerations that go into designing solutions to take advantage of these replication strategies, right? So let's say, use one of the customer examples you cited. Are there specific best practices around how to configure the cluster to support those? Is it more kind of, one-off, or each one has to be dealt with individually, or there's some general best practices that can be followed?
Yeah, there are some best practices. That's a very good question. And I will show you here with the stretch configurations. Actually, we can see first stretch and then asynchronous replication at a high level. And this is exactly what we're going to cover here in this slide. And we also have like this small diagram that could help us talk about this a little bit more. So for stretch clusters, and this is also when you can see here that we're talking about replica 3. So this, for people, to give them a little bit of context if they're not aware about replica. So in Ceph, when we have a pool, that a pool is really a logical segregation of data. So you could have a pool for object storage, you can have a pool for block. So at the pool level, we normally configure two things. There are more, but the most important things for this topic is the failure domain. So you can set the failure domain for your pool. And by failure domain, what we mean is that we're going to store one copy per failure domain. It could be host, it could be rack, it could be data center, like in this example. So that's one thing that we need to be aware of. And the other one is actually the replica schema or the replica count. So here we have in this example, replica 3. When we talk about replica 3 is that we have 3 full copies of the data per failure domain. In this example, our failure domain is data center. So what is going to happen, as you can see in this slide, is that we actually have 1 copy of the data per site. Advantages of this is that it's going to allow us to tolerate a full site failure, and we're going to be able to keep having business continuity. The client is going to keep reading and writing without noticing, completely transparent, and also really nice for the operators because there's no need for kind of failovers, failbacks.
Manual failover. Yep.
Yeah,
Yep.
completely transparent. The only thing that I wanted to mention here, if you see there in brackets, we also say min size 2. So this is a concept from Rados, from Ceph, and the idea is that to be able for the user to keep doing reads and writes, you have to be at the min size. You have to have available the same number of copies as you have in min size. So in this example with min size 2, we
can
at
tolerate
least
one failure.
Right? Yeah, we need to have at least 2, and we can tolerate 1 failure.
Got
Why
it.
is this important? I have here just a quick example. No? So let's say that we lose one full site is gone, our data center is dead, nothing is going to happen for the clients. The IOs are going to continue transparently, everything is working okay. But in this case, let's say that we also get in a second data center, while our failed data center is dead, is completely down, we get one more failure. Let's say that one
node failure.
Yeah, one node failure goes down. So this is going to be that in some point, not all of your objects, but some objects are going to also lose one replica, the ones that were in that node. So what is going to happen here, as you can see very quickly, Randy, is that you are left with one copy of the data. So you have gone under min size. And what is going to happen is that the IO is going to freeze for the client. No, so he can't do any reads and writes to those objects affected. No, it could be one or more objects. There's not a defined number there, but your client IO is going to be affected. There's no data loss because we still have one copy. Right. And as soon as we get back that node that went down or that full data center, the recovery is going to happen. We're going to copy back or the updates that we have missed to these nodes, and everything is going to continue working. But we're going to have that IO freeze in the client because until the replica account goes over min size.
Got it. Okay. So are there ever situations where min size could be set to 1? And I mean, you guys presume you don't want to do that probably because you expose yourself to additional data loss potentially, right?
Yeah, that's why we tend to avoid it. It's true that it is possible. So technically, I mean, it is possible. And let's say that you have lost 2 data centers completely. They're going to take months, let's say, to be restored or repaired, and you are left with only one replica. You can manage the min size as kind of an admin operation to allow you to have client IO maybe recover something that is very critical access data, maybe ideally in read-only, because you don't want to make modifications with only one copy. So to your question, it does work. We try to avoid it at all costs, and especially with the stretched clusters, where you also have network splits, another dangerous thing. Yep. That's why I wanted to very quickly also mention, and this is what most of our customers are doing, is actually have Replica 6. It's true that this is going to increase your costs for the raw storage that you need, but it also provides you with a nice advantage. So if you compare it with the previous solution that we had, Replica 3, here we have Replica 6. And what that means is that we have 2 copies per data center. So if we go like into the previous example, okay, we lose a full data center, both of our replicas have gone, we still have client IO because we have 4 copies and we have min size 3. But now you can see what happens, that even if we lose one OSD, we lose one node, we're going to lose one replica, but the client IO is going to continue without any problems because we still have 3 copies, as you can see here. So the min size 3 is actually in what is expected, and you can continue without losing your client IO. So this is quite popular, and we have several customers using Replica 6, and it's also what we actually recommend, because when one site goes down, you sometimes don't know how long is it going to take to recover it. It could be 1 hour, but it could be 1 month, and then you could be in trouble with what's remaining in your other 2 sites.
So one additional, I guess, configuration or design question is presumably each of the sites should be configured identically, right? But is that a hard requirement? Can there be some flexibility in terms of scale and configuration for each site?
That's a very good question. So if, normally with Ceph, you know that you can be very flexible and you could mix and match and have different sizes. Ideally here, if we are talking about pools that are going to have the same functionality, the same usage between all of the sites, you would scale in. So if you add one node to one availability zone, you would need to add the same number of nodes to the other availability zone. So you always grow in the same set of sizes, because otherwise, because you have to copy one object or two objects to each site for every write. If you have an odd number or something that is not the same in one of the sites, you're not going to be using all of the storage. It's going to fill up, no, even if you have free space on the remaining ones. So in this specific case, you had a very good point that you need to grow in the same sets of numbers.
So increment capacity on the same in each availability zone. Okay, makes sense.
Yeah.
Cool.
Yeah, before moving forward and on the topic that you mentioned about architecture and design, you also see here that the latency ideally is going to be less than 10 milliseconds round trip time. And I have a slide afterwards that help us understand why this kind of requirement. But between 8 and 10 milliseconds, we wouldn't go higher than that, and we don't support it because just the performance is going to be too bad really as an experience. Now, maybe for object storage use case, you could go a little bit higher, but ideally you don't want to go over those numbers. So that's also something very important to take into account if you are planning on designing a stretch cluster with Ceph. You need to have data centers with dark fiber and be in these ranges, no, for round trip time.
Yeah. Okay. So it's going to be typically more of a campus level kind of split versus, metro or geo distances. Yeah. Okay.
Yeah. That's more or less what we see with the clusters that are being deployed. As I said, there's some customers for object storage that they're using Stretch that you could go a little bit higher, because as we know, maybe object storage doesn't have that kind of low latency requirement when you are doing puts, but normally we wouldn't recommend going over that.
Got it. Okay. Awesome.
I have here one more thing to talk about in Stretch cluster, because we do get, especially I see this quite a lot in Europe. I don't know your experience, Randy, but there are not that many customers that have like 3 full sites close together, low latency. So for those kind of customers that they have 2 sites with very low latency and maybe a third site, but it doesn't have that kind of high level functionality, you can also use what we call like the 2-site stretch cluster in Ceph. And the main idea here is that you have 2 data sites that are connected with that 10 millisecond or even lower latency. And then we have a third site that is actually the tiebreaker that is not in the data path. So no data is going through that site. So it could actually have 100 milliseconds or even higher. So what we have seen customers is doing is they're actually running it maybe on a virtual machine on a cloud provider. That's going to be completely fine. So it's very, very flexible. You just need to have like 2 solid data centers for the data, and then the monitor one, that is our tiebreaker, could be almost anywhere, no?
Gotcha. Yeah, definitely. As most customers are, getting out of the data center business, as they like to say, finding 3, campus level sites is pretty unusual. So this configuration is definitely very popular here. Yep.
Yes, and the nice thing with this one is also you have replica 4. As you can imagine, on the data sites, we have 2 copies going to the example that we were talking about before, 2 full copies of the data in each of the sites. If you lose one site, you still have 2 copies available. And the really nice thing, and I won't go too much into details because maybe we can discuss this topic specifically for Stretch cluster and show you a demo on the next session, but when you have only 2 copies on one site left, actually automatically, because of the stretch mode, he's able to change the min size to 1 only during the time that he's in, let's say, degraded mode, because you only have one site. So in that way, even if you have another failure, you're going to be able to, the clients are not going to notice, and you're going to be able to do reads and writes. So that's a very nice feature available for the 2-site stretch cluster. and it only needs Replica 4 in that case.
Very cool. So this is great. This is a perfect level overview. I think people are not always aware of the advanced kind of DR and availability and resiliency features that Ceph has to offer. I think people think of it more as kind of a massively scalable, high performance object store, and there's much, much more to it. So this is great. And I think our next episode will be kind of going deeper on stretch cluster configuration, maybe with a demo and showing some of the operational characteristics. So I think that'll be very cool. Awesome. Well, this is great. I guess a quick last question for me: where can people go to learn more about this? I mean, I see some links on some of your slides here. I assume that goes to Seismic or goes to some documentation where they can read up on this. Or
yes, there is a really nice series on multi-site replication that is in the IBM community.
Oh, okay.
So
Cool.
in the Exchange IBM community, and it's public also, that maybe we can make the links available. Also, they are linked in Seismic, to your point. So if you go to Seismic, you will find them there anyway. But maybe we could make those posts or those blogs available, because there's 6 or 7 posts. So it's kind of a series, and it covers with a lot of detail, especially all of the asynchronous replication side of things. So we can cover that there if people want to know more.
Yeah, I'll find a link, and somewhere on the screen here, I'll put a QR code, and you can link out to those blogs and check them out. Awesome. Daniel, this is great. Really appreciate your time. This is a great overview. I think this is going to be super helpful for our tech sellers and our architects and sellers. So thanks everybody for taking the time to watch. Stay tuned for future episodes, which are going to go a little deeper on some of this technology. And Daniel, thanks again. And we'll be chatting again soon.
Bye.
Thanks.
Bye. Thank you.